So we'll be shortly starting our problem session. If there is any doubt before this session to be started, please let me know so that it will be helpful for you to understand and uh, solve the questions even more better way. So if there is no question, we can start with the problem session. So here, predict the product of the reaction, where you can see you need to first identify what is the substrate and what is the oxidant that you are taking. So here, your substrate is your uh, allylic alcohol, and you're using an oxidant here. This is your oxidant in presence of titanium catalyst. This is your catalyst, and this one is your substrate. And here you are using a minus di this configuration of your diethyl tartrate, which is your chiral system. And in presence of, firstly, in presence of an oxidant and an allylic alcohol, and in presence of titanium catalyst, this is nothing but your epoxidation. Now, if oxidation would make an epoxide, this product is not an epoxide, this is not an epoxide. So these two options are anyway out. And in presence of this minus DEP, you end up making the epoxide in having an oxygen bond above the plane. So this is dependent on the stereochemistry that we are talking about. If it is plus DEP, it would go below the plane, how the mechanism it is working. So this is the right option, the option C. And this is your Sharpless epoxidation. The Sharpless epoxidation is catalyzed by, this is straightforward question because we have seen that Sharpless epoxidation of allylic alcohol that has been catalyzed by titanium, and the catalyst is nothing but titanium oxygen isoprotoxide, where titanium is in classical oxidation state. So the option D is correct. Now, please try the question number 3 if you can. This is also an example of Sharpless epoxidation. You can see the product substrate is allylic alcohol, and we are giving a source of oxidant here again in presence of the catalyst. And here the feature that has been changed, which is plus DET. So depending upon what chirality you are introducing into that one, depending on that, your product will be changed. So in case of minus, oxygen was coming above the plane. Here it would come below the plane. And you need to keep in mind that OH, there are two options where it is below the plane, but one side OH is as it is, and other side it is double bonded O. So the answer that you have to be careful that OH is not going to be affected at all. It would remain a function intolerant. Only the alkene part, which is going to be epoxide. So option A is the right option. So just look into the direction of your oxygen, epoxide oxygen, and click onto this one. That would be a wrong answer. You end up getting a negative mark. Now, the next question that we have is the following reaction is catalyzed by. So you again have an alkene, and this is PHIO. This is your oxidant, and this is your alkene, which is a substrate. And you're again getting an epoxide, right? So here, this is not a sharpest epoxidation, but it's a epoxidation of alkene. And this reaction is catalyzed by which catalyst? So it means like it is asking about whether it is catalyzed by titanium, it is catalyzed by zinc, it is catalyzed by manganese, or so and so forth. So we have already seen there was a selene manganese 3 complex, which actually in treatment with the oxidant, it would form your selene, Mn plus 5 double bonded to oxygen, and this transfers the oxygen to alkene. So basically, this reaction is catalyzed by manganese. If it has been asked, like which oxidation state is in plus three oxidation state. So it's also which that we have discussed here. Now, another simple question, which is water gas shift reaction involves the oxidation of what? So you have four options. So water gas, we know that it's a water gas shift reaction of carbon monoxide and water. So this is the oxidation of CO, which would give you a CO2 as an oxidized product. So option A is the right option. Moving ahead, Fischer-Tropsch synthesis involves the reduction of what? So we have seen that water gas shift reaction gives you the oxidized product from CO2 to CO2, and Fischer-Tropsch would do the reduction of CO2 forming carbon monoxide. So option B is correct over here. Don't get confused with the two different reactions. The seventh question, the components of synthetic gas is. It's very straightforward that we have seen the synthetic gas formation. It's H2 and carbon monoxide. So option A and C are the right options. Now, the production of CH3OH from synthesis gas is catalyzed by. So you need to see like how you can get from COH2 synthetic gas and it is forming CH3OH, how this would work. And we have seen that Fischer-Tropsch synthesis is actually works with iron and copper system, and therefore the formation of methanol from the synthesis gas is catalyzed by the copper. And in that case, if iron is also there, that can also work. The question number 9 is the role or the roles of iodine in Monsanto acetic acid. So firstly, we have seen that when you have a CH3OH and to make it to go and get an oxidative addition into the rhodium system, that's not possible because this is less electrophilic compared to the CH3I. So this is more electrophilic, making CH3 more electrophilic. So to generate methyl iodide from methanol, that is correct. Let's see whether other options are correct or not. To de-accelerate the oxidative addition step, no, it actually fastens the step. To reduce the rhodium 1 to rhodium 0, that is also not correct because it undergoes the oxidative addition from 1 to plus 3. So these two options are wrong. And the last to felicitate the formation of CH3COI, that is correct because the pre-product is your CH3COI and in presence of water, when it is being treated with the water, it forms your acetic acid. And the last question, that catalytic cycle of the Monsanto process involves a reductive elimination of the product as. So what is your reductive elimination product? So it is not just don't look at the Monsanto acetic acid process and you just click onto the acetic acid option. It is actually the CH3COI, which is being released from as a reductive elimination step. And when it is being treated with water, it releases the CH3COOH plus HI. H2O will split as H plus OH minus. This H and this I would form HI and OH goes and attack onto your carbon middle. So with that, our problem session is also over. If there is any question or doubt, please let me know. Otherwise, you're free to leave the session at any point. We are done with the session. I'll wait for a few more minutes for others to ask the question if there is any. Thank you.